This is the fourth part to the potentiometer series of videos, okay, in which we are going to look at the third use of a potentiometer, which is to find the internal resistance of a given cell. Okay, so we have battery connected, okay, whose EMF is V, and AB is the potentiometer. We have the lower circuit connected, okay, so we have E, the cell, whose internal resistance R is to be determined, and we have an external resistance R, which is connected to a key, and these two are connected to the galvanometer, which is connected to the jockey. Okay, so what we do is, in the first case, we keep the key K open. All right, key K is left open such that this is not playing any role whatsoever. All right, then after, so only the upper arm of CD, is coming into play right now, and let us try to find the null point. This is not coming into play, remember. So say for example we achieve the null point somewhere over here, we find the null point somewhere over here. So when that is the case, what happens is delta VAJ, the potential difference across this, has to be equal to the potential difference across CD. Now the potential difference across CD will simply be E, okay, because at null point, remember, there is no current flowing through the internal resistance, therefore there is no voltage drop whatsoever, so the potential difference across CD will simply be E, and of course this is not coming into play, so therefore the potential difference across CD will be E. Okay, so that is what you've written. Delta VAG is V by L x1, where x1 is this distance, and x1 is this distance. So delta VAG is V by L x1, and delta VCD is E, so therefore E has to be equal to V by L into x1. That is my equation number 1. Now next thing what we do, case 2, what we do is we close this key K of course. Okay, so when we close, so this lower arm of CD is also coming into play. This is also coming into play. This is coming into play, of course. Okay, this is also now coming into play. All right. Now, the moment we close this key, what happens is the position of the null point is, of course, going to change. Okay, the null point, say for example, is achieved somewhere over here. Okay, at some distance x2. This is distance x2. All right, so what happens is delta VAJ, the potential difference across AJ. Okay, here is where we are finding the null point, say for example. So delta VAJ will be V upon L into x2. So this is understood. All right, now what you need to understand is, although we've achieved the null point, that is, there is no current flowing through the galvanometer, what can still be happening is, there can still be, because of this cell, there can still be current flowing in this lower circuit here. In this circuit, there can still be current flowing. There can be some amount of current still flowing in the lower circuit. Only thing is, there is no current flowing from this lower circuit through the galvanometer, and no current flowing to the upper circuit, no current reaching the upper circuit, or so to say, no current from the upper circuit reaching the lower circuit. But what can be at null point, of course. Okay, but at null point, what can be happening is there can still be current flowing in the lower circuit. There can still be current also flowing in the upper circuit. There current will be flowing, in fact. Current will be nicely flowing in the upper circuit. Okay, they can also be current flowing in the lower circuit. But there is no current flowing from the upper to the lower circuit, or from the lower circuit to the upper circuit. All right. So what we want to do is, we want to find out what is the current flowing when this key is closed. We found out what is delta VAJ. We've done that, which is V upon L into x1 here. V upon L into x2 over here. This is when the key is closed. All right. So now there will be current flowing in the lower circuit, which is given by I is E upon R plus R. This is the amount of current that is flowing in the lower circuit. Now, how do we get this? Let us look at the circuit, the lower circuit. So the lower circuit is this. This is the internal resistance R. This is a key which is closed, of course. Okay, a very crude, rough picture. So this is E. So this is the lower circuit. This is the lower circuit. All right. Now what happens is, you can see this internal resistance R and the external resistance capital R, this is closed. Okay, they are in series. Okay, so what is the current flowing? The current flowing will be the total EMF divided by the total resistance of the circuit, which is R plus R. So this is the current flowing. Okay, so that is exactly what I've written here. The current flowing in the lower circuit will be E upon R plus R. Okay, all right. then after the potential difference across CD, therefore the potential difference across CD will be E minus IR. E minus IR. Now how do we get that? See, we are saying current is flowing in the lower circuit. Now since current is flowing in the lower circuit, so current is flowing through the internal resistance also. Now since current is flowing through the internal resistance, there will be some voltage drop across this internal resistance. Okay, and the voltage drop across internal resistance will be the current flowing through it multiplied by its resistance. Okay, so what is the potential difference across CD? You can see when we want to find the potential difference across CD and we look at this circuit, this upper arm and this lower arm, they are in parallel. When we are finding the potential difference across CD, this circuit, the upper arm and the lower arm, they are in parallel. Okay, so whatever is the potential difference across this upper arm here, the potential difference across the lower arm has to be the same. And the potential difference across this upper arm is simply E minus IR. The terminal voltage, in other words, okay, the terminal voltage across this upper arm will be E minus IR, because there is voltage drop across this. Okay, so the potential difference across CD, which is delta VCD, will be E minus IR. Okay, and we've already checked how much is I. So I is E upon R plus R. So therefore delta VCD is E minus, this is the value of current into the internal resistance. Then after simplifying, we get delta VCD is, the LCM is R plus R. Okay, ER plus ER plus ER minus ER. So these two, they cancel each other out. Check the mathematics yourself. Okay, so delta VCD is ER upon R plus R. All right, now so delta VCD is this much. But at null point, what is true is, remember we've closed this key. Okay, so at null point, what should, and we've achieved the null point at this point. So at null point, the potential difference across VAJ, which is V upon L into X2, has to be equal to the potential difference across CD. So to say, this value, when the key is closed, delta VAJ is this much. This thing has to be equal to delta VCD, which is this, and that is exactly what we've done. At null point, delta VAJ is delta VCD, okay, or delta VCD has this value and delta VAJ is this much. Okay, so this is our equation number 2. And what is our equation number 1? Equation number 1 is this. E is V upon L x1, which is the case when this key K was left open. All right, when this key was left open, delta VAJ was this much, V upon L x1. Delta VCD was simply E. Okay, so E is V upon L x1. This is the case we got when the key K is open. So therefore, dividing equation 2 by equation 1, or from equation 1 and 2, we get E upon this is equal to V upon L x1, which is the value of E from equation 1, and this is the value we get from equation 2. So when we divide, okay, so E, they divide each other out. This R plus R goes to the numerator, so R plus R divided by this R is equal to V upon L, the potential gradient, they divide each other out. We get x1 upon x2. Okay, then after simplifying this when we separate this, we get 1 plus R by R is equal to x upon x2. So R by R is x1 by x2 minus 1, and therefore the internal resistance is capital R into x1 by x2 minus 1. Okay, so this is therefore the value of the internal resistance of the cell which we can get using a potentiometer. Okay. To understand these videos properly, okay, repeat the videos and see. All right, repeat the videos and see. Try to understand everything very, very clearly. Okay. Based on these things only that we have done, you will get numericals, but the numericals will be simple numericals actually. Okay, if you understand these things clearly, it should not be much of a problem for you. All right, so check the videos and study well.